Hi, Yuji. Okay, so it's just you and I, perhaps? Okay. Other few people know this book. So I got this book, I think, early 2000, and then started reading it. And then I was allowed to join a SIP conference. And who knows about this kind of upper side conferences that took place in Paris? I think the first one I joined was 2003. So I got this nice rucksack. It was 2008. I couldn't find the 2003 bag. I think it was kind of black shoulder bag or something. But such conferences are always nice to meet important and interesting people. Like I met Henning, Henry, and Jonathan. I guess you all know the three guys because you may have read RFC 3261 or something. When I was there, I was just asking a few questions to them, like, would you ever take an airplane if you know that SIP is going to be used in the ground infrastructure of air traffic management? I got some feedback, and I have some chocolate, and you can guess who actually said what. So there was one statement, there is one stable protocol, because I was asking, okay, how mature is SIP, and then can we start to implement it and things like that. And I got a feedback from one guy, I'm not sure if you want to use the Morse code because this is a very stable one. And one guy said, I would take an aircraft or airplane if ATM communication is based on SIP, but I would like to know more about hardware and software. So we've seen hardware and software may fail. It could be bad implementations, but the protocol is not an issue. And then there were some other ideas like having a specific network for ATM instead of using the public internet. So who wants to take a try, and who said actually what? So I have Henning, Henry, and Jonathan, and I have 4 of these statements. Just guess. That's right. You get a chocolate. Okay. And 2 and 4, that was the same person, just to help you. Sorry? No. So I'll help you. So 1 was Henry. 2 and 4 was Henning, and Jonathan was 3. So grab some chocolate for the coffee break afterwards. With that knowledge, I started actually introducing SIP, the protocol, to Frequentis, to be used for voice over IP and to be used for air traffic management. That's a quite interesting environment in air traffic management because you have to deal with analog radios. So we use still VHF, UHF radios in air traffic communication. And this is AM-based. It's analog, and it's organized in sectors. So you have different airspaces like en route, approach, then you have the towers. You have typically ATC centers. They are interconnected, so there's cross-border communication. During that time, it was actually analog communication they used. So they had analog lines to the radios. They had analog lines to neighboring ATC centers, so cross-country and cross-border. And in 2004, actually, we started thinking of replacing this with IP infrastructure, so packet-switched infrastructure, and to enhance it a little bit. So instead of having just analog audio to interconnect, to have more information getting from the radio, from the receivers, or sending to the transmitters. As there is a long migration in that environment, it's also important there to include legacy technologies. So typically radios not replaced at the same time as you replacing those kind of air-ground, ground-ground voice communication systems. So there's also kind of interworking with legacy technology, not only for the air-ground segment, but also for the ground-ground communication. So looking at the features in that environment, Most important, it's for situational awareness, is this kind of party line feature. And this goes along with actually analog radios. So everyone that has a receiver can listen to what is going on. And if there are aircrafts managed in a specific sector, they use the same frequency. And if a controller gives a command to a pilot, then every other pilot in that sector can listen to that command. So they are all aware of what's actually going on. There is, especially in Austria with the mountains, there is a kind of technology called carrier offset mode. So this is just to increase the sector coverage. So these are radios. They operate at the same frequency with a slight offset. And for that, it's very important. That was kind of a tricky part in specifying these protocols for voice over IP and ATM is the transmission time adjustment, because you need to transmit actually at the same time if you have different radios working in a carrier offset mode. So you need to know, okay, what's the latency from the VCS or from the air ground services to the radio sites, and then you have to adjust. So you need to adjust to the longest end-to-end delay. Then there's also something that has impact on, or that increases actually the latency. It's called coupling mode. So if sectors are combined, sometimes during night operation, if there are not that many aircraft flying around, then a transmission from sector A is forwarded to sector B, and it goes through the ground infrastructure to the ground segment of the communication. Then in the receiving direction, you have this kind of best signal selection feature. So you get some information about the signal quality from the receiver, and this is sent to the VCS. And if you have multiple receivers, the VCS or the services that are central would then pick the best signal and provide this to the controller working position. Since we have a party line, as mentioned before, there are some situations where step-on transmission happens. So if some two pilots are just speaking at the same time, for instance, then they have a simultaneous co-transmission. This is SCT, and this can be detected by radios, and the radios can provide this information to the controller. So that's actually kind of safety feature, because in other analog environments, the controller is not aware that this happens. It just cannot hear anything because the signal is kind of scrambled. And with that information, you can indicate, okay, there was a kind of step-on transmission, and then you can set specific measures. Then, of course, lockout. So if 2 or 3 controllers are operating at the same radio, you need to make sure that only one is speaking. And there might be some priority PTT, so if there's high priority, then this one will win. And then there's also kind of radio remote control, or knowing about other participants who have selected the radio. So for this specific feature, we actually use subscribe notify mechanisms in SIP. Then there's also ground-ground communication. There are also very interesting features like instantaneous access code is kind of intercom feature. You just press and talk, and the other one can listen. And you can monitor what is going on the other operator positions. And there's kind of feature that comes from the FAA. It's called override call. It's similar to instantaneous access call, but it can have actually can be chained. Yeah? So A calls B, B calls C, C calls D, and so on and so forth. And there could be some loops, which is actually bad because there's always audio in place, and then you get an audio loop. So you need to cover this as well in your protocol. Then, of course, legacy interworking. So we have MFC, that's analog, SS7, ATS QSIC. The digital versions of it are still in use in some places. Then we have conference calls, monitoring and recording. So you see a lot of interesting and challenging features. And actually, you can cover this using SIP and RGP. But this requires kind of working groups, and there was 2004. It was, I think, the second year when I was at Frequentis. we joined EuroK working group 67. So in the presentations, I have those things underlined that have a link. So if you're interested in, just click the link and you get connected to that site of EuroK. And so it lists everything we did. And I just took a few important milestones of the timeline. So yeah, starting in 2004, then we had this Vienna agreement. That's another story I'm going to tell you with the next slide. We started some interoperability testing very early in 2008. Then we had a revision, actually the first revision of those protocols. So they're called EDs, EuroK documents. There was also a reference, which was very important by ICAO, so it's the international organization, and working group by reference to the ED document, making it a little bit more global. And then we had first field trial where we used this in a kind of operational environment. And this picture was taken in 2009. It was kind of a historic moment. The person talking said, "Oh, it works." And this is a historic moment. And I took the picture. And you see here a lot of legacy stuff in the back. So that was actually replacing an analog connection from France to Germany with voice over IP. So he was using the legacy equipment, and then there was a gateway translating from MFC to voice over IP. And on the other side, it was actually the same. And then they had a nice conversation, and it worked. And I took a photo and also captured with Wireshark. Still no one knows about that, but I thought it could be quite interesting in the future when talking about this at the Kamailio World, for instance. Yeah, and then we had a lot of, actually the working group is still active. So we had, in March this year, we had the meeting number 55. So I joined actually all of them except one I missed. Now we are currently updating the documents. There was a major revision in 2020 since we got a lot of new features coming from the US, from the FAA. We also had some international testing in 2019 in the US. So what about this Vienna agreement? Very interesting drawing, which actually happened at the EuroK Working Group 64 meeting in Vienna. That's why it's called Vienna Agreement. And actually the day before, it was September, we had a nice social event in Vienna at a Heurigen. I think it's called Weintavern or something like this. And yeah, it was really a nice evening, and we got friends. Yeah? So, you know, in such working groups, it's always difficult because you have to deal with customer, you have to deal with your competition. But we got friends, and then we agreed on, okay, let's focus on the interfaces between the different elements. And the elements are actually a voice communication system, which may consist of legacy internal parts, a supervision system, a radio side, and recording. And we have two major interfaces, or three. There's the interface for radio and telephony, and the interface to the recorder, and of course to the supervision. But a very important detail here is, I'm not sure if you can read this, there were some discussions about SIP and H323, because during that time there were kind of competing protocols. There was SIP and there was H323, and no one was actually sure what the future will look like. And this is just my experience. I'm not sure if you're also taking part of working groups and technical committees, who actually is in like 3GPP or ETSI or something like this. So here is my experience. So what typically happens, there's a kickoff and everyone pretends to know everything. So we are ready in 6 months, let's say. And then there's a lot of discussions about requirements. So everyone says, okay, this is how I'm doing it. Is this the most and easiest way? And let's do it like that way. So everyone talks about it, no one agrees. And discussions are going on. And then sometimes one volunteers to write a draft. Yeah, so we start with a draft, and others silently disappear, just waiting for the phase to comment. And then there's kind of comment apocalypse. That means, okay, you get back a lot of comments and completing suggestions, and usually you start this kind of battle in track changes. Yeah, documents are not readable anymore. You have some version conflicts sometimes. So it's a kind of mess. And then this happens very often. And tomorrow I'll be at the ETSI meeting again, and I think we will continue that. So it's about definition wars. So people start talking about and spending a lot of time about terms. So naming it, for instance, endpoint node or thingy or whatever. So this always happens. And then after a long time, you get the first draft. And you remember the timeline. We started with this ATM working group in 2004, and we had the first draft in 2009. So it was kind of 5 years discussing and defining things. But the one thing that really happened is, and this gets back to the Vienna Agreement, we had to decide once to say, okay, we use ZIP or we use HD-3. And the chairman was just asking who is going to explain us ZIP. And actually, I volunteered. I said, I can talk a little bit because I got this nice book. And I was in Paris at the conference. And then he asked, okay, who will explain us HD-3? And no one volunteered. And then he said, okay, well, since no one volunteered to explain HD-3, we just use ZIP. So that's really happened. And then we actually moved on with ZIP, which I guess was a clever idea. Okay, this leads to emergency communication, another topic where we have this kind of working groups and a lot of discussions, and perhaps quite interesting for MNOs and VoIP service providers. So here is also an environment where we have to deal with voice over IP and, of course, ZIP. It's the IMS, if it's voice over LTE, for instance, that interconnects with emergency communication or with emergency centers. And there's something in between that's called ESINet, which interconnects ambulance, fire, and police. So it depends on which country you are. You may have just one center, or you may have several centers that are interconnected. And if it's just one, it's like a 112 center, and those have to talk to each other. We have native multimedia in the end devices. We have automatic in-vehicle devices for the NGE call. And they're actually sharing data. And here, what important thing is the service URN, which addresses a service and not an endpoint. And there are some elements in between that are dealing with routing and mapping. A few features here. I think most important is the nice, this is still red over there, is the screenshot of a mobile device. So you see it's video, it's audio, and it's real-time text, so that's natively supported. Real-time text means RFC 4103. We have, of course, location information that needs to be shared for routing and dispatching. We need to support language and modality. So some people just would like to select a specific language and modality means, okay, I would like to text, I would like to have sign language, and so on and so forth. Then there is callback. Daniel mentioned stereo shaking, so I'm happy to see that stereo shaking is also supported by Kamailio. Then there's call transfer, which means transferring from one emergency control room to the other. Which is actually a media bridge in between, because you cannot just lose connection to the calling party. Then you have logging, recording, and some additional data to be shared as well. Short timeline again. I think everything started somehow with defining this uniform resource name, URN. So there's an RFC from 2008 from ECRIT, so they started to introduce this for emergency communication. Then there was a US industry collaboration event #1 where they started to test. There are some rumors that it didn't work that well, so they had to redo it later on, but this was actually kicking off a series of such ICE events. Then I did the batch for Kamailio to support service URLs. That was 2012. Then afterwards, we could use Kamailio for testing at the Etsy plug test event, which also kicked off a series of events. And I think 2018, I did a pull request for the Lost module a long time ago. And then we used this implementation actually in Austria. It's the Tech 112 digital emergency communications for accessibility, where we have those things in place, and then a series of Etsy specifications for emergency communications. And very interesting, in 2025 this year, so we're currently working on accessibility and interoperability for emergency communication. So this is not a TS, it's an EN, it's a harmonized standard, and that's kind of higher level, and if we get this published, I think that will change a little bit the communications environment in Europe for emergency communication. There were some nice stories, and it's just one example about trees, roots, and forest guides. So you may have heard Lost is organized in a hierarchy. So those Lost servers are responsible for specific regions. They're called service regions. And the forest guide actually oversees all the lost trees. And I remember at the beginning there were some discussions, okay, where is actually the root of a tree? So is it the bottom or is it at the top? And that's very important because forest guides are sitting actually at the top. So they are the root of this technical tree and not at the bottom. At the bottom are the leaves. And so we had quite interesting discussions about that. Mission critical communication is also quite new, and the scope is just the other way around to the emergency communication. So emergency communication is from the citizen to the PSAP, public safety answering point, and mission critical communication is just the other way around. It's for dispatching and just talking to the officers on the street. This is also using voice over IP, running over the IMS, and I think the important thing here is that you get higher priority on the network. So if you use a commercial network, you can just request this higher priority, and if there's a congestion in the network, you should still get connectivity. There's also legacy interworking involved, which is also being standardized, and in between packet switched infrastructure, voice over IP, and also connections from one center to the other center. So they may team up and combine their talk groups, leading to some features. So mission critical push to talk. Roman is going to talk a little bit about that in the afternoon, I guess. You have also this kind of group communication, like in ATM. You have priority and preemption. You have private and emergency calls. So you have late entry, so you can join a group and listen to the group if it's already ongoing. And there are still, I think, not that much devices around that support direct mode operation, which means you don't need the infrastructure. You can communicate directly. And then, of course, authentication and encryption. Then there's MC video. You have private and group calls, the video streaming, so one source and others are just listening to the source. And then there's also mission critical data. It's short instant messaging, private and group, and file sharing and location sharing. So this is the timeline, actually just copied from 3GPP with different releases. I think it actually started earlier than 2012 because there were some Nokia phones that used to have a PTT button. It was push to talk over cellular, and this is actually was the first idea of implementing this kind of thing. And I think it was not that much different because they used RTCP application-specific signaling things for that. So it's a kind of request-response flow control thing, and it's quite similar to this push-to-talk over cellular. So that was earlier, but the mission-critical communication began in 2012. And then you may use that link. There was in 2017 a nice demo in Austria we did together with A1, Atonet, and Emergent Solutions. So it was it's really a nice video because it was on a lake in Carinthia. So if you click that button, you get connected to the YouTube channel. Then they continued defining the RX interface, so very important to support quality of service. And then they just extended capabilities, focus on 5G and nowadays 6G. And 2025, because that's very recent, a few colleagues were there 2 weeks ago. There is a kind of Schneeberg railway in Austria. So it's Schneeberg is the highest mountain in Lower Austria, and it's very close to where I live. So for me, it's 20 minutes by car. And Schneeberg railway takes passengers up to 1,800 meters. So I think the mountain station is somewhere here, and this is the peak of Schneeberg. And since this season, trains and control room have been equipped with an MCX solution. And if you happen to be there, they still run trips on a historic steam train. I'm pretty sure it's also equipped with MCX. And yeah, again, I just invite you, if you happen to be in Austria, it's very close to Vienna. And actually, you can see this mountain from Vienna. If you're south of Vienna, where Frequentis is located, you can see the mountain. And yeah, that's actually leading me to almost the last slide. So this kind of trials and testing, so I've experienced quite a lot, and just some funny facts, like the first one completely crashing with a late STP offer just because it shall not be used. So we had this in the specification, and there was some implementation that just died because someone did not follow the specifications, or RTP stacks that are not compensating clock drifts. So we had some transmitters with such problems, and we just kept the session open for 24 hours or just over the night, I guess. And then on the next day we test PTT. We've seen, okay, PTT just was received, but there was no audio to be transmitted. And then we figured out, okay, there was no compensation of the clock drift. So clock drift's happening. And then we had a lot of social events or social media posts. Usually social media posts are more than test scenarios to be tested. And I remember we had a fire at night after testing a week of 911 interoperability. A few of the guys, it was I think at 4 in the morning, just left to the airport because they had an early flight. But for me it was in the middle of the night. And what always works is just the last statement. Be conservative in what you do and be liberal in what you expect from others. So that's concluding my presentation, and thanks a lot.
Thank you. Maybe one quick question, since we are a little bit late. And now it's the coffee break, so everyone probably needs to wake up, and hopefully we'll be able to sort out the right side panel. What happened? Any question from the audience? If not, from my perspective, this with next emergency specification or standard, somehow in European Union seems that many countries prefer to go their way. It's still getting to convergence and this decision to use same in all European Union at least, or not yet there?
Yes, that's the idea, and that's why I've mentioned the EN 303 919, which is actually heading into that direction, saying to have something that is common throughout Europe, because it's harmonized standards, so all the national STOs need to agree on that. And this will then also be referenced by the regulators. And the problem is, and this is why we're circling around, is that there is some technology around and no one's actually saying, okay, use this. So for instance, the Commission doesn't say use this, it more or less delegates this to the member states. And then what's happening is that they're just looking into their own solutions. But with that kind of standard, the
very quick one.
Idea is to have it harmonized.
Yeah,
yep.
I know the idea is to have it, just if it's more political wish now or not.
Yes, it is. Okay. Yes, it is.
Yeah, the small one regarding the Sturchecken. So if that's the same standard goes for the Europe than that goes for the US, or there are some differentiations in that case?
That's a good question. Usually it's the same. Yeah? So I'm currently testing with the US because in Europe we haven't tested that much. And it's the same implementation. The only difference, I think, is that we also have an RPH head assigned and not only the identity itself. Yeah. But this is also valid for the US, and it's being used for the callback as well. Yeah.
Okay, thank you. If you have more questions, hunt Wolfgang today, as I said, because tomorrow he has to leave. Before going out to the break, we have coffee outside and also some bits to eat.